Hello, welcome all to another Pure Study Buddy. We have started with the question bank for 12th class student and we have discussed on the topic differential equation in the previous video. Today, we will deal with a very interesting topic and very scoring topic, that is probability distributions. So let us understand few basic before we actually proceed.
Probability distribution. Before we understand this concept, let us know what is a random variable. Random variable is a real valued function defined on a sample space of a random experiment. So it is very important when we are calculating the distribution of a random variable, we figure out what is called probability distribution. There are two types of random variable, discrete and continuous. A random variable is said to be discrete if the number of possible values, outcome or values it takes is finite. Continuous random variable. A random variable is said to be a continuous random variable if the possible values of this random variable form an interval of real numbers. For example, continuous random variable include height of a tree or a forest, weight of a student, and daily temperature. These are all the example of continuous. And rolling a die, tossing a coin, these are the example of discrete random variable. Probability distribution of discrete random variable. Let us consider the experiment of throwing two dice and noting the number on the uppermost face of the two dice. The sample space will be 1, 1, 1, 2 up to 6, 6. So total number of points in the sample space will be 36. Let x denote the sum of the two numbers in any single throw. So that means addition of two numbers will be the values taken by the random variable and they are finite, so it is a discrete random variable. So we want to calculate what is the probability associated with the random variable x taking a value 2, 3 up to 12. These are the number which are going to add, which appears on the surface when we roll two dice. So on the screen you see the different values of random variable x, that is starting from 2, 3, 4 up to 12, and the corresponding probability, that is 1 by 36, 2 by 36, 3 by 36. These are the corresponding probabilities. So the table showing the different values of random variable x and its corresponding value is called probability distribution table. Let us solve the first problem now. A fair die is thrown. Let x denote the number of factors of the number on the upper surface. You need to find the probability distribution for random variable x.
So a die is thrown and your random variable x is the number of factors of a number on the upper surface. Like when we are rolling a die, we will be generating a number 1, 2, 3, 4, 5, 6, right? So these numbers will appear on the upper surface of a die. Now for each of this number, we want to identify how many factors this number will be generating or they will be having if x is a random variable. So for the random variable x, it will take the values for the number of factors the number represented on the upper surface. So that should be clear in your mind first of all. Now, what we will be getting if I say x1, that is x is when small x takes the value 1, when a die is rolled and one number appears on the upper surface. So what are the factors? How many factors it has? One has a factor only 1. In the second case, when I say when small x is equal to 2, when small x is equal to 2, what are the factors for 2? It is 1 and 2. Similarly, for 3, x is equal to small x is equal to 3, it will be equal to 1 and 3. When x is 4, that is the number on the upper surface is 4. So how many factors? 1, 2 is also factor for number 4 and number 4 itself. Then for x is equal to 5, when small x is 5, again it is 1 and simply 5. For x is equal to 6, small x is 6, that is it will be 1, 2, 3 and 6, right? So how many factors? It is a number of factors. Number of factors. So how many number of factors? Here it is 1, number of factors 2, 2, 3 and it is 2 and it is equal to 4. Right? Now, what x is denoting? The number of factors on the number on the upper surface. So x is taking, this capital X is taking the values 1, 2, 3 and 4. Right? These are the values taken by the random variable x. And now for this we want to estimate the probability. So probability 1 is x is taking a value 1. So when it is happening, x is only taking a value one time, right? So that means when x small x is equal to 1, this is what is happening, right? So what I can write here, how many times it is occurring? Out of 1, 2, 3, 4, 5, 6, out of 6, only one time it is occurring. Then for P2, that is capital X is taking a value 2. So for how many events this x is taking a value 2, capital X is taking a value 2, 1, 2 and 3. So that means when x is equal to 2, when x equal to 3 and x equal to 5, that is 3 times out of 6, capital X is taking a value 2. Similarly, you can calculate for x is equal to 3. So 3, x is taking a value 3 only one time when x is taking a value 4. So it is only one time out of 6. Then what we have, probability 4. So that is x is taking a value 4 and is taking a value 6 and that is occurring only one time. So this is how you are going to calculate the probability for P1, P2, P3, P4 for all this value. So if I want to write down as a distribution table, when we are writing probability distribution table, we write the values taken by the random variable x and the corresponding probability. So it is 1, 2, 3, 4. So for x is equal to 1, probability is 1 by 6. For x is equal to 2, it is 3 by 6. For 3, it is 1 by 6. And for 4 is 1 by 6. Now let us add 1 plus 3, 4 plus 1, 5 plus 6, 6 by 6. We know that summation of all probability, it should add up to 1 and that is what it is satisfying. So the probability that we have added, that are right. So this is a way you first of all look into the problem and identify what x is, that is random variable x is indicated. And once you identify that, then find out what are the values this random variable x can take. And then for each of these values, what are the corresponding probabilities that you have to calculate. And then you have to write, this is a probability distribution. So the required answer is probability distribution is given by, and then you can write a table. So this is how you are going to solve. It will come for 3 marks question.
Question 2. The probability distribution of x is as follows. So you have been given a table for the random variable x and their corresponding probabilities. You have to find the value of k, probability that x is less than 2, probability that x is greater than or equal to 3, probability that x lies between 1 and 4, and cumulative value for f2, that is probability that x less than or equal to 2.
Let us solve the next problem. So in this problem, you have been given a table which is a probability distribution table. So like it is given, it represents probability distribution. Sum of all probabilities should add up to 1. So for finding out the value of k, we can add all probabilities saying that as it is given, table represents probability distribution. This implies summation of all pi's should add up to 1. So that means 0.1 plus k plus 2k plus 2k plus k, it should be equal to 1. So 2 plus 2, 4, 4 plus 2, 6k is equal to 1 minus 0.1. So 6k will be equal to 0.9. K will be equal to 0.9 upon 6 is equal to 0.15. That is what is the value for k. Now as we have figured out the value of k, next question is to find out the probability that x is less than 2. When x is less than 2, what are the values random variable x can take? That is what you have to identify first. So x will be taking a value starting from 0. So it will be equal to 0 plus probability of x will take the value 1. It is less than 2. So only these two values you are going to add when x is equal to 0 and when x is equal to 1. So what is the probability? It is 0.1 and here x is equal to 1, that is k, that is 0.15, and when you add up it will be 0.25. That is what is the answer for the first one. Now for the second one, third is probability that you have to find out when x is greater than or equal to 3. So now tell me what are the values this random variable x can take. X is greater than, so it will start from the value 3 onwards. So it will be capital X taking a value 3 plus probability that it is equal to 4. So for finding out the value of k, we can add all probabilities saying that as it is given, table represents probability distribution. This implies summation of all pi's should add up to 1. So that means 0.1 plus k plus 2k plus 2k plus k, it should be equal to 1. So 2 plus 2, 4, 4 plus 2, 6k is equal to 1 minus 0.1. So 6k will be equal to 0.9. K will be equal to 0.9 upon 6 is equal to 0.15. That is what is the value for k. Now as we have figured out the value of k, next question is to find out the probability that x is less than 2. When x is less than 2, what are the values random variable x can take? That is probability for x is equal to 3. It is 2k. So that is 2k plus probability that x is equal to 4 is k, that is 3k. And what is the value of k? 0.15. So that is 0.15. 45. That is what is the answer for the third question one. So now, first of all, let me identify what are the values x can take. So it is 1 less than equal to x less than 4. So that means it starts from 1 and it is less than 4. So it is 1, 2 and 3. These are the values the random variable x is taking. So if I want to find out the probability that this is the range given to you, 1 less than equal to x less than 4. So we are not including 4, right? So x can take the value, it starts from 1, then it takes the value 2 and up to 3 it is taking a value, x is taking a value 3. So let me add, for 1 it is k, for x is equal to 2 it is 2k, and for x is equal to 3 it is 2k. So how much it is? 2 plus 2, 4, 5k. That is 5 into 0.15. So it is 0.75. That is what is the answer. Now the last one, that is f of 2. You need to find out the cumulative frequency. So f of 2 is nothing but probably that x is less than or equal to 2. So starting from 0, x can take the value 0, then x can take the value 1, and x can take the value 2. So let us add the probability, 0.1 plus k. Then for x is equal to 1, it is k, x is equal to it is 2k. So it is 0.1 plus 3k, it is equal to 0.1 plus 3 into 0.15, that is 0.1, 0.45, that is 0.55. That is what is the answer. So this question may be asked for 4 marks. It is very easy to simplify it. Only thing you have to remember that probability distribution, if it is given to you, sum of all probabilities is 1 always. So you can calculate the value of k. And then for finding out a specific probability, you need to identify what are the values taken by the random variable x, right? And then once you know the values, then corresponding probability from the table you can look up and simply you have to add. So it is very easy to solve such type of problems.
The mean of random variable x is defined as summation of xi pi. That is the product of the values taken by the x and the corresponding value of its probability. And variance is denoted by summation of xi square pi minus expected value of x the whole square. So when you have the value of variance, you can obtain which is called standard deviation as a square root of variance. Find the mean and variance of numbers randomly selected from 1 to 15.
This question, you have been given that x is a randomly selected number from 1 to 15. So that means here the sample space will be from 1 to 15. So from this number, you are selecting few numbers. You need to calculate what is the mean and variance for them. So formula for mean, it is equal to the expected value of x, that is mean. It is equal to summation of xi into pi. And for the variance of x, the formula is summation of xi square pi minus expected value of x the whole square. That means to calculate mean and variance, we need the corresponding probabilities. So here, as x is a random variable, so probability of selecting x1 will be same as x2 will be same as probability that x is equal to 15. So all the probabilities will be same, and that will be, so probability x is equal to 1 will be equal to probability that x is equal to 2 will be equal to probability that x is equal to 15. So each has same probability, equal probability. So it is 1 by 15. Now let us calculate the mean. Expected value of x will be xi into pi. So if I want to write the probability distribution, it will be, you can write the x and pi. So here number 1, 1 by 15, number 2, 1 by 15, and so on, 15, 1 by 15. That is what is the probability distribution table for the given problem. Now, it is simply the multiplication of these two. So it will be 1 into 1 by 15 plus 2 into 1 by 15 and so on plus 15 into 1 by 15. So I can take out 1 by 15 common outside. So it is 1 plus 2 up to 15. So we can apply the formula for sum of natural number. And what is that formula? N into n plus 1 by 6. Our n is 15 here. So I can simply simplify it like it is 15. 15 plus 1 is 16 upon 2. So that means 8 is the answer. Now for the variance, it is summation of xi square into pi. So that means xi square will be 1 square into 1 by 15 plus 2 square into 1 by 15 and so on plus 15 square into 1 by 15. Again, and minus the expected value of x the whole square. So this is what is the formula that I am making use of. Now here, I can take out again 1 by 15 outside. So what remains inside is square of all the terms. 1 square plus 2 square up to 15 square and minus it will be 8 square. We have already calculated the expected value of x. Right? This is what we have already obtained. Now here, what I get, it is 1 by 15. And now it is sum of squares of first n natural number. And for that, the formula is n into n plus 1 into 2n plus 1 upon 6. So what is the value that I get here is n is 15 into n plus 1, that will be 16 into 2n plus 1. 2n means 15 into 2, that is 30 plus 1, 31 whole upon 6 minus 8 whole square. So here what I can get. Now, when I reduce it is 18 into 31 upon 3. Again, 8 is common, I can take it outside. It remains 31 upon 3 minus 8. And when you simplify it further, it comes out to be 18.6. So, it is a very simple question. Again, it carries 4 marks. So, when you are preparing for these topics, from the point of view of your exam, it is really very easy to score marks on this topic, as well as there are really very few formulas that you need to remember. Right? So, today we discussed about the topic probability distribution. This topic is pretty easy and very easy to score marks in the board exam. So, very interesting topic and very important as far as examination point of view is concerned. We'll come up with an interesting topic called binomial distribution in the next video or next video lecture. So, stay tuned. Do subscribe, like and comment and press on the bell icon. See you very soon. Thank you.